Welcome back, learners, into today's video, right, where we are still continuing discussing something about the circle, right? So if you are to follow the previous videos by the link down here, please, you'll be able to see that we are discussing the properties of the circle, tools used to solve problems related to the circle. So here we were discussing about the cyclic quadrilateral. I introduced it, and we are aware that the cyclic quadrilateral is the quadrilateral that has its vertices lying on the circumference of a circle, and those vertices being the points of which are referred to as the concyclic points, A, B, C, D as such. I connect A to B to C, then to D. What I have there is A, B, C, D as a quadrilateral, but being it having the vertices lying on the circumference of a circle, we call that one as a cyclic quadrilateral. And the points A, B, C, D are referred to as concyclic. Right, so we discussed and measured the properties about the cyclic quadrilateral, and we observed there are two. Right, one of which is just is talking about the sum of the interior opposite angles, which are like in this case, we're talking of this angle and that angle. We said if we add the angle A and angle B, which are facing each other, being opposite to each other, and again being interior angles, the sum of which is 180 degrees, right? Secondly, we also observe that if we extend any one side of the cyclic quadrilateral, like say I've extended DC to point T, maybe point Z, right, then what we have is an exterior angle, right? I can describe that exterior angle by notation like X, right? So what we observe, just like by using the protractor, we found that the angle X is just equal to the opposite interior angle. In this case, we're referring to this angle. So it'd be like X1 is equal to X2. Right, so for today, we need to prove the two properties. You see, sometimes in exam, they ask you to prove that sum of the interior opposite angles is 180 degrees. How do you show that? And secondly, the exterior angle is equal to the opposite interior angle. How do you show that? Right, so please stay tuned and look at the steps that we're going to use in proving these two properties. So let's go straight and start proving the property one, where we need to observe that sum of the interior opposite angles of cyclic quadrilateral are supplementary or add up to 180 degrees. Right, so here we go, and stay tuned and be able to follow me on how we prove. The guided steps should not be forgotten. Right, I'll remove this one out now. Right, so the first is to show that to prove that talk of the opposite interior angles add up, or just simply we say are supplementary. Right, meaning to say they add up to 180 degrees. Right. So from what I said, it's much that we need to prove a particular property or theorem. The first thing is to at least draw the diagram of which. Like say here we're talking of the opposite angles of the quadrilateral are supplementary. So which means I'll do here, the first thing I'll do is to show those angles, to identify those angles in the cyclic quadrilateral. So if you talk of a cyclic quadrilateral, it means first of all, you need to produce a diagram which is circular. So here I'll have my diagram which will be produced from the circle. Right? Look at this. Right, because most of the time in geometry, you can't just prove a fact without a diagram, because you always need a point of what? Reference. How do you really show that the opposite angles of cyclic quadrilateral are supplementary? Right, so when you're proving, first of all, draw the diagram of which we did have to see the cyclic quadrilateral itself, and then thereafter identify which angles are you referring to. Right, so you always begin by drawing a circle for you to produce a cyclic quadrilateral, like the one I have here on the chart. Right, so it means in your case, you're going to draw the diagram like this one. Next, what do? Indicate the angles which are of your interest. So in this case, the angles which are of my interest will come from the quadrilateral itself. So which means if I got that circle, I need to produce a quadrilateral, but its vertices should touch the what? Circumference of the circle for it to be known as the cyclic. So here I have my ruler, and now I'll come and draw the cyclic quadrilateral like this. Point to that one, connecting to that one. I'll have this one like A, this is B. Look at that. And then to have a complete cyclic quadrilateral, I need to further attach 4 sides to the shape. So I have got another side here connected to maybe to go this one as a D. And again, I also have another line connecting from A, from D, heading towards maybe to go what? C. And then I join the B like this. So you can see what I'm doing here, and this is what you are supposed to do each time you like to prove a particular theorem. Right, so here we have A, B, C, D as a cyclic quadrilateral. But my interest is the opposite interior angles. Which are these angles? Right, so from what we discussed, we really saw that the opposite angles which are referred to here, the interior ones, are the angles which are facing each other. Like here, we talk of angle A is opposite to angle C, and angle B is opposite to angle D. So what we want to do is just a matter of proving, is angle A and C supplementary? Or when I add angle A and angle C, are they giving 180 degrees? The same we go for angle D plus angle, that's the angle B plus angle D. Do they give us 180 degrees? Right. So I'll just prove for one pair. What I'll do for one pair of the opposite angles, it is similar to the other. Right, so what you have done is this one here. So what you do here is just like you can mark the angles of which and say I'm trying to talk of this one. This can be labeled as maybe angle X, and then you talk of this other angle here, which can be labeled as angle what? Angle Y. So in short, you want to prove that if X plus Y is 180 degrees. Now, procedures, how to write this one neatly. As we saw in those previous videos, as I was proving one of the theorems, we always begin by writing what we have in the diagram. So it means the first step here, it will be given, right. So what is it that you're given? You talk of what is there in the diagram. So here you may just describe diagram just in briefly with little of information that is very relevant in your proof. When you be proving that is. Right, so here we are given, you can just say in briefly to say the figure as above, in which what is more important here when you be proving is the center, right? Because whatever we do here, it will be an issue that will be related to the center. As we'll be targeting angle X and Y. So here you'd say O is the center. That now of a circle. Right. The next thing, what is that you do? You're going to tell us that we're going to do with that diagram. What is it that you're going to do with the diagram? You apply it here. Because an examiner has to really know. It's not only you that you know it, but somebody who is going to mark. So here, what you want to do is just to prove that opposite angles are supplementary. So here you not like that statement, but rather like the angles under discussion. So here we are referring to this and this angle here, and we are going to indicate here that I want to prove. Right. So what? You say that angle X is plus angle Y is equal to 180 degrees. That's what we need to do. Right. Having done that, then you look at the diagram as such. Is the information enough for I to show that X plus Y is 180 degrees? As I earlier indicated in those previous videos, as you can observe in the link down here, you'll be able to say that I talked of the issue of the adding something on the diagram in case that diagram doesn't have enough information. So like in this case, we really see that the diagram itself, as the virtual look of it, doesn't have enough information. So we have to add something here. So whatever I add will be part and parcel of the what? Construction. So here we like this stage here, construction, like that. Right. So what is it that I feel like is important in this case? Right. What is needed here is simple view, just connect D to O and also B to O. Right. Just like coming up with truly die. Right. So here I'll join point, that is one D to O like this one. It comes to the center and this line again will come to the center like this. Right. So that's it, but you may join it with what? A straight line yourself. Here it's just a board on the board here, you know what, we are brief, but still we can do that one. Right, so I've joined D and B to O for a reason that you see it here when we'll be proving that one out. So first, allow me to write that. So here we'd say construction, just light, join D and B to center O. Right. So what? How is that one going to help us? To show that this one is equal to this one. Sorry, this one plus that one is 180 degrees. Right. So whatever you're going to explain by that, you have to write it on the last stage. And this stage is about the proof itself, just like a noun. A proof is this one. So you write it down here to say proof. Right. So what is it you're going to tell us? So everything that I'll write here in the proof will be referred to the figure. So what I'll have here on the opening stage, I would say with a reference to the figure. Right. We'll have this in discussion here. Right. But that I have got this figure here and I've done the construction joining D to O and B to O. You're going to realize that by the previous stage, the talk of the properties that we discussed, more especially the first one, that talks of angle at the center is twice angle at the circumference. You really see that one again here is true. And that is the property that will help us to prove that this plus this is 180 degrees. Right. Like say, for example, look at this. If I talk of this arc here, this arc, arc DAB is obtaining an angle at the center, which is this angle here. Look at that. And the same arc DAB is obtaining angle at the circumference, which is what? This one here. So from what we discussed, we said that angle at the center subtending by a particular arc is twice angle at the circumference. So you expect this angle here, if this one is y, this one must be what? 2y. Right. The same if we come on this other side here, here is also an arc, which is arc DCB, is also subtending an angle at the center. Now it is now a reflex angle, which is this one here. Look at this one, this reflex angle here. And that same arc is also subtending an angle at the what? Circumference. It means now the angle again at the center, subtended by this one, this must be a major arc at the center, is also twice angle it's subtended on the what? Circumference. So which means this one again is also what? Double the other one on the circumference. So this one should be 2 what? Talk of 2x, like that. Now we're going just to try to add it and factorize this one here. Let's say if I add this and this one, what does it give? Then after, if I factor that one out, you see the result yourself. Right. Now, let us have this one here. In that, I'll write what I've just mentioned there up there to say angle. So here that we're using the same points. So I've described this one as obtuse, this one as reflex, because we'll be using the same points D or B to describe this angle and that angle. Right. So it may be in short, I should just write in brief because of time. We'll be able to see that this angle here, I'll just talk of the angle that's a reflex. Let me just describe it by type of an angle because you can get lost. We begin with this one here, angle D or B, which is an obtuse. I'd like to say obtuse. Angle B or D is equal to B or D, that one is 2y. Reason, angle at center is equal to 2 times angle at the circumference. Now, this other one now, here, this one here, this angle on the other side is a reflex angle. Right, but I assume you're using the same letters. So I would like to now say reflex angle B O that's a D is equal to what? 2x. The same reason. Angle the same is twice angle the circumference. I've already explained that. Right, so we all know about that one. Now, then what? Let us now consider this situation. This is 2y, this is 2x. Now, we know for sure that this is just like a point, and we've got two angles, that one and this one. We understand that when we add angles, when we've got angles at the point, the sum of which is what? 360 degrees. So what we expect here is just like angle 2y plus angle 2x. When they're added, they give us a value of what? 360 degrees. So now let us capitalize on that property and see what we're going to get about x and y. Right, so this one we'll have it here to say, let me rub here. Right, if we try to sum up that two angles, right, so therefore, if we have 2y plus 2x, we know that is giving us 361 degrees. Why? Angles at a point. Right. And that is true. So if you'll be able to follow me, the properties I'm using here to work out the, to show that the opposite angles are supplementary. Just breathe. Angle at the center plus angle at the circumference. The next I'm talking of angle at the point being 360. So now, if I've got this plus this one is that one, we can factorize this one out. The left hand side will give us a common factor is 2. So you have with 2 here. Here gets y plus x. And this one is 361 degrees. So if you can try to divide both sides by 2, which is here, in order to have x plus y, this being the coefficient of x plus y, which is our interest, because our target is to see is x plus y, giving us 180. You're going to realize that then when I divide by 2 on both sides, what I'll have here is like I'll return a certain value on the right hand side. Look at this. 2 cancels with 2. 2 here, 1. 2 here, 100 and what? 80 degrees. Right. So what we get from there is just like x plus y. That's y plus x is it what? 108 what? Degrees as such. So it means in this case we have been successful. So upon the look of it again, the x and y are the opposite angles of the cyclic quadrilateral. So from that, we say really that is true, that say the opposite angles of a cyclic quadrilateral are supplementary, or they add up to what? 180 degrees. Right, so please just take the main point in here that can help you to prove this. One, I repeat, we talk of the first property about the angle subtended by an arc at the center twice angle of the circumference. Very important. Secondly, use the angles at the point, only 2. Right, so that's it about it. Now, let us also go to the second property, where we need to see if I extend a line now to somewhere else, what do I get now if I extend any side of the cyclic quadrilateral? I'll obtain exterior angle. How is that one now related with the opposite interior angle? Right. So let's get now into the second property, where we need to see that the exterior angle is equal to the opposite interior angle. Right. So we have this one here. To talk of the exterior angle is equal to opposite interior angle. This is issues about the cyclic quadrilateral. Right. So now, in the same vein, you also need to do the same. Produce a diagram, right, at the first step. Like this case, I'll still more calm with another chart, just to make things very orderly. No shortcuts. So I have like this one here. as my other diagram. In this new case, we're going to draw it directly because you don't have charts in the book. Right. The next thing, what is that you do? The same guided step or similar guided steps in the proof, just like the framework of which have to be indicated. Right. So for this one, I will not take much of our time because the issues here are just clear. So what I expect from you is really to take note about the properties that are helping us to show that a particular what they say theorem is true. Right. So like here, what we want is the diagram. You can just draw it like that, one up to that as indicated area. A, B, then you join here. That is C, then come here. That is D, like that. I have my quadrat. So there as it was, that is your figure. So I think I may not even light other steps that are already there procedurally that you light, given the figure as above, in which A, B, C, D is the cyclic and O is our center by the same, by the first property. You can light that step about the given, similar one. Then what do you want to do here? Our target is simply to prove. So I begin from here to prove what? Right. My interest is only to prove that if I extend one line, like say in this case, I extend this line to this point here, I'll have this one go as an exterior angle. Right. So let's take this one is angle X, and again we refer to this angle here, angle Y. Right. So that's what I want to do. I just want to prove that, look at this one. Angle X is equal to angle Y. By the discussion, that's what we had. We measured that this angle is equal to that one. Exterior angle is equal to opposite interior angle. Right. Construction here, none. No need for construction, just like a dash. You see? Right, that's the point. If you don't have anything to light, the information is enough, just like that. Then go straight to what? Proof. So you always light with reference to figure. Right. You can follow that step, what we had in the first one, discussion when we were proving the opposite angles are supplementary. So with reference to the figure, meaning this one here, we want to prove angle A or Y is equal to angle BC, whatever point here, X or X is 180 degrees. So what we want here to do is just like to take note of the properties that can help us to show that. So the properties that we need are just very brief and very direct. One is just this property that we have discussed about the opposite angles are supplementary. Right, how do I use it? Look at this. Suppose I insert this angle here as angle B. We have this situation then. Y, you're going to see there that say angle Y plus C, that say angle B is equal to 180 degrees. Reason, the opposite angles of what? Cyclic quad. That's what we have just discussed. And again, using the same angle B and X now, you're also going to realize that say angle X plus angle B is also 180 degrees. This is angles on the straight line. So you can also write that one, say angle X plus angle B is 180 what? Degrees. Here you have angles on straight line, like that. So look at this. If this expression, the sum of this one, of Y and B, give us 180. The sum of X and B is 180. Then definitely we expect that this one is equal to this one. So here, conclude that say angle Y plus angle B is equal to angle what? X plus angle B. Right. What if we subtract B from both sides to maintain up the and or set the balance up the equation? What do we have? So we have to subtract the same quantity on both sides. There you are not violating the rules of the equation. Right. So subtract angle B, we remove B on this side, we subtract B from that side. What we have at the end, we only have Y on this side and only have X on that side. B is subtracted. Right. So as such, we'll be able to see after subtracting B, we'll have angle Y is equal to angle what? Angle X. Therefore, it means the property of which is really true, that the exterior angle is equal to the opposite interior angle. Right. So this is what we had this day in this video. Right. So thank you very much for following this one up. So there's no need for exercise this time around, but I need you to do is just like an assignment where we need just to take note of the properties that we have used to prove this theorem, and also the properties we have used to prove that other theorem. Thank you very much for being together. Remember the video down, the link down here, always be followed each time you are revising this topic. You begin right away from the beginning up to where we're going to stop. Thank you very much. We'll meet in the next discussion.